On the 1st of July 2025, a telescope in Chile pointed at an ordinary patch of sky and found something that was not ordinary. The object it detected was moving too fast. Its trajectory was too curved. Every calculation confirmed the same conclusion. This was not something born in our solar system. It came from somewhere else, from another star, from another planetary system that formed in a universe billions of years older than our Sun. It had been traveling across interstellar space for longer than Earth has existed, carrying chemistry that our own solar system has never produced, and it had just arrived. Scientists named it 3I Atlas, and from the moment it was confirmed as only the third interstellar object ever detected passing through our solar neighborhood, every major telescope on Earth and in orbit began pointing in its direction. What they found in the months that followed would divide two of the world's most powerful space agencies, split the scientific community down the middle, and raise a question that nobody has fully answered yet. What exactly is 3I Atlas? And why does everything we have measured about it refuse to fit neatly into the category of ordinary comet? The discovery was made by the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, operating from Rio Hurtado in Chile. Within 24 hours, astronomers confirmed the object's interstellar nature through one number alone, its orbital eccentricity. A comet native to our solar system has an eccentricity close to 1. Anything significantly above 1 is moving too fast for our Sun's gravity to hold, which means it came from somewhere else entirely. The eccentricity of 3I Atlas measured approximately 6.1, 6 times the threshold for interstellar origin. It was not a close call. It was definitive. The object was racing through our solar system at roughly 58 kilometers per second, about 221,000 kilometers per hour, on a trajectory so hyperbolic that nothing in our solar system had ever produced it naturally. And its orbital inclination, approximately 175 degrees, made its path essentially retrograde. It was orbiting the Sun backward relative to all the planets. An object arriving from deep interstellar space should enter our solar system at a random angle. Instead, 3I Atlas was traveling within about 5 degrees of the ecliptic plane, the flat disk on which all our planets orbit. The statistical odds of that happening by pure chance are less than 1%. Scientists noted it. Nobody had a clean explanation for it. What followed the discovery was one of the most intensive observational campaigns in modern astronomy. The James Webb Space Telescope analyzed 3I Atlas's light spectrum, while the object was still more than 3 astronomical units from the Sun, far colder and darker than the region where most cometary activity is expected to begin. Even from that distance, Webb detected carbon dioxide gas dominating the coma, along with carbon monoxide and water ice in the nucleus. The NASA SPHEREx mission observed the comet across 8 days in August 2025, gathering near-infrared data that confirmed the CO2 domination and provided the first detailed look at the object's icy surface composition. And then, in October 2025, as 3I Atlas swept past Mars at a distance of roughly 18 to 19 million miles, something happened that changed the public face of this discovery entirely. NASA went quiet, and the European Space Agency stepped in. NASA's silence during October 2025 was attributed officially to a U.S. government shutdown, a funding lapse that temporarily suspended non-essential federal operations. The timing was real, but the effect, whatever the cause, was a stark contrast. While NASA's data channels went dark and official updates stopped appearing on agency websites, ESA moved in the opposite direction. The agency's ExoMars, Trace Gas Orbiter, and Mars Express spacecraft, neither of which had been designed for interstellar comet observation, were reprogrammed on the fly by engineers who extended exposure times, adjusted software parameters, and redirected communication systems to chase an object 100,000 times dimmer than their usual targets. ESA published the resulting images within hours of capturing them, released the raw calibration data publicly, and invited the global community to process the images themselves. What the Mars orbiter showed was a pale sphere of light surrounded by a soft, expanding halo, the closest, clearest images of 3I Atlas taken from another planet's orbit. In that moment, two of the world's dominant space agencies presented two completely different faces to the same historic discovery. One opened its doors, the other, for whatever reason, was not in a position to. Hit like and subscribe right now, because what the combined data from all those instruments revealed about what this object actually is, and where it came from, is the part that truly stunned everyone who read the analysis carefully. The chemistry of 3I Atlas is unlike anything in our solar system. That is not a dramatic exaggeration. That is the scientific conclusion published in Nature in June 2026 by a team led by NASA Goddard, Space Flight Center planetary scientist Martin Cordner, Using James Webb's near-infrared spectrometer, researchers measured the isotopic ratios of carbon and hydrogen in the object's coma. Carbon comes in two main stable forms, carbon-12 and carbon-13. The ratio between them in solar system objects follows a known range. In 3I Atlas, the ratio was significantly different. Similarly, the water in 3I Atlas's coma contained approximately 30 times more deuterium, a heavy hydrogen isotope, than any comet native to our solar system. These two isotopic signatures, taken together, pointed to a single conclusion. This object formed in a planetary environment that was chemically and physically different from ours. An environment that was older, much older. A universe that was poorer in heavy elements because the stars that forged them had not yet had time to live and die in sufficient numbers. The best estimate, based on the isotopic data and kinematic modeling, places the formation of 3I Atlas between 10 and 12 billion years ago. Our solar system is 4.6 billion years old. The universe itself is approximately 13.8 billion years old. This comet formed when the universe was barely 1 to 2 billion years old, in a planetary system that no longer exists, around a star that lived and died before our sun was ever born. The organic chemistry added another layer. Observations using the Atacama Large Millimeter Array, ALMA, detected methanol and hydrogen cyanide in the coma at concentrations that significantly exceeded anything measured in solar system comets. Methanol constituted approximately 8% of the comet's vapor composition. Hydrogen cyanide production rates were sharply elevated throughout the observation window. Both molecules are considered prebiotic, meaning they are building blocks of amino acids and complex organic compounds, the precursor chemistry of life. They are not unique to 3I Atlas. Solar system comets carry them too. But the abundance of both in this interstellar visitor was exceptional. Researchers at ALMA reported that the organic molecule concentrations were unprecedented in comets observed from our solar system. The object that arrived from 12 billion light years of cosmic history was carrying, in extraordinary quantities, the chemical ingredients that life on Earth is built from. The object's physical behavior was equally strange, despite being the largest interstellar visitor ever detected, with a nucleus, estimated at approximately 2.6 kilometers wide, and a total mass potentially exceeding 30 billion tons. 3I Atlas showed almost none of the wobble or trajectory deflection that jets of escaping gas typically produce in comets. In a standard comet, outgassing acts like a set of small thruster rockets nudging the object off its gravitational path. The implied non-gravitational acceleration from 3I Atlas's outgassing was so small, relative to its mass, that it was nearly undetectable, something that large should have been pushed harder by the forces it was generating. Instead, it held course with a stability that multiple researchers described as remarkable. Its polarimetric readings were equally unusual, showing an extreme negative polarization branch that had never been observed in any solar system comet, implying that its dust or ice grains were shaped or composed in a way that nothing in our own neighborhood matches. Record after record fell. The oldest object ever observed in the solar system, the most organic-rich interstellar visitor ever measured. Polarization values with no known precedent, a mass-to-acceleration ratio that defied standard cometary models. And then there were the questions that certain scientists began asking very carefully, in very measured language, that pointed toward a more unsettling interpretation. Harvard astrophysicist Avi Loeb, who had previously argued that the first interstellar object, Oumuamua, might be of artificial origin based on its anomalous acceleration, noted that 3I Atlas's combination of traits was extraordinary even for a natural object, an ancient origin, prebiotic chemistry in unusual abundance, a near-perfect alignment with the ecliptic plane, a mass that resisted the forces acting on it. Loeb suggested publicly that the scientific community should not close the door prematurely on the possibility that some interstellar objects might carry more than just rock and ice, that the universe, given its 12 billion years of head start on us, had more than enough time to produce civilizations capable of sending things across the dark between stars. He was careful with his language. He did not claim 3I Atlas was artificial. He said the data did not rule it out, and that ruling things out without evidence was not science. The response from mainstream astronomy was immediate and largely dismissive. But dismissal is not the same as explanation, and the things that needed explaining did not disappear because scientists preferred a natural origin. The observation campaign that surrounded 3I Atlas became the most internationally coordinated astronomical effort in history. China's Tianwen-1 probe confirmed the object's light signatures from near Mars. The UAE's HOPE orbiter gathered infrared, readings of the surrounding gas. The European Southern Observatory and ALMA in Chile jointly reported that the comet's emissions pulsed in regular intervals, a roughly 11-hour cycle that Webb had also detected independently. ESA's Jupiter Icy Moons Explorer observed the object after. Perihelion. The Virtual Telescope project streamed live observations from Italy. Hundreds of amateur observatories across 6 continents contributed brightness measurements. The openness of ESA's raw data stream allowed citizen scientists and independent researchers to run their own analysis. Astronomy, for a brief window, became something that belonged to everyone, and what everyone found, working from the same data, was consistent. 3I Atlas was unlike anything humanity had previously encountered. Its age, its chemistry, its orbital behavior, its physical properties, every single dimension of this object exceeded the boundaries of what our existing models of comets and interstellar objects had predicted. What 3I Atlas leaves behind is not resolution. It is an open question of tremendous consequence. The star it came from is almost certainly dead. The planetary system that produced it has not existed for billions of years. The comet itself has been traveling through interstellar space, irradiated by galactic cosmic rays processed by the cold and dark between stars. For longer than Earth has orbited the Sun. It passed through our solar system in a matter of months, reached its closest point to the Sun in late October 2025, swung past Earth at a distance of about 170 million miles in December 2025, and is now continuing outward, never to return. It brought with it chemistry that our own solar system cannot produce, isotopic signatures that rewrote what we thought we knew about where comets can come from, and a trajectory that statistical analysis says should not have happened by chance. Whether the explanation is extraordinary geology, extraordinary luck, or something we have not yet found language to describe. The question will remain open long after 3I Atlas fades beyond the reach of every telescope we have. Like and subscribe, because the next interstellar object could arrive at any time. And the question 3I Atlas forced us to ask, whether the chemistry of life travels between stars, is one that changes the meaning of everything depending on how we answer it. There is a detail about 3I Atlas that does not appear in most coverage of its discovery, and it is worth sitting with. Before 3I Atlas was officially named and confirmed on July 1st, 2025, it had already been photographed. Pre-discovery images of the object were found in telescope data going back months before the formal announcement. The object was there, in images already taken, already processed, already sitting in databases, and nobody recognized it for what it was until after it had been identified the first time. We had already seen it. We just didn't know what we were looking at yet. This is how the universe tends to work. The most significant things pass through the frame of human attention unrecognized, waiting to be understood retroactively. 3I's Atlas was in our data before we knew it existed. What else is already there, waiting in the archives for someone to run the right analysis at the right time and realize that the universe left something behind that nobody noticed on the first pass? The polarimetric anomaly, that extreme negative polarization branch that had no precedent in any solar system comet, was processed by a team at the Very Large Telescope in Chile using the 4S2 instrument. The value they measured, a minimum of approximately negative 2.77% at phase angles of 6 to 7 degrees, sits completely outside the known range for natural comets. Polarimetry measures how light bounces off the dust and ice grains in a comet's coma. The values produced depend on the shape, size, and composition of those grains. Nothing in our solar system produces polarization signatures like this, because nothing in our solar system formed in the same conditions as 3I Atlas. A universe 2 billion years old, a star system with subsolar metallicity, cosmic ray irradiation over 10 to 12 billion years of interstellar travel. The grains in that coma carry the physical record of a history that nothing else humanity has ever studied shares. And that record, in the form of polarization values that break every chart we have calibrated to our own solar system, is the most direct evidence we have that whatever built 3I Atlas built it in a place and time so different from our own that the comparison strains language itself.